So how can we achieve higher performance out of a plain balloon? By adding serration technology. Serration technology is based on well understood physics principles used in many industries. For example, a serrated knife slices through a loaf of bread more easily than a non-serrated knife. Because it has many small points of contact, the applied pressure is greater at each point. A simple example of a material that has been serrated is seen in a notepad. A serrated piece of paper will easily tear away from the pad along that serrated line. Physics principles show that serrated material is more responsive to directed energy and will tear more predictably. Now let's talk about incorporating serration technology to an angioplasty balloon. This is truly differentiating in both design and its mechanism of action. The Serranator has multiple serrated metal strips. These strips are on the outside of the balloon. The Serranator's mechanism of action is unique. As the Serranator inflates and contacts the artery wall, the strips create multiple interrupted lines of scoring. These serrated lines are more responsive to the balloon's energy. In other words, the serrated regions yield or relax, enabling predictable and controlled lumen expansion along those lines. By incorporating serration and inflation, low pressures are sufficient to achieve a full balloon effacement, which causes less damage or barotrauma than high pressures. This optical coherence tomography image is a post-Serranator treated artery from the prelude study. In this view, the arrows indicate the serration effect and associated lumen expansion. Here is another image from the prelude study. This intravascular ultrasound demonstrates the serration effect in hard calcified plaque. The calcium is disrupted, which enables the artery to relax and the lumen to expand. The Serranator restores blood flow by creating minimal injury angioplasty by directing the balloon energy along the serrated line, resulting in lumen gain even in calcified lesions by giving the vessel a place to expand, achieving full balloon effacement at low pressures. In other words, creating the largest lumen possible without flow disturbance or injury to the artery.